What's up, YouTube? It's your boy. JOHHABRAHAM. And we are back. Oh, I was not here for like 2 days, eh? 2 days, eh? Yeah. 2 days I was not here. Goddamn. What's going on? Well, I was having my lab course in analytical chemistry. I was having my lab course, and after that I was just too tired. Huh. But you know what? I just have two more experiments left, which is gonna be like next Monday. I'll be done with next Monday, so I got exams coming up. I gotta focus. I gotta lock in. You heard of those? You heard the word lock in? Yeah, lock in. Oh shit, I got classes too today. Goddamn. Yeah. I was just trying to connect, what's it called? My Kick account, but don't worry, got it connected. I just gotta get into my YouTube stream, yeah, this one, and change the description. There's gonna be a stupid ass ad as part of Restream, which I need to edit. Discord. Damn, we're going all the way back. Oh, come on. Shit. Direct messages, what is that? Why is there a direct message? I don't know. There we go. 15th. Oh shit. Man, I feel bad, bro. Well, at least I'm back. I'm back. Shh. I don't get the direct message. What the fuck you mean? Organic chemistry? Let's go. Where was I last time? 15 minutes. 1 hour. 45 minutes. 30 minutes. 20 minutes. Okay. There's a rotation lock? No. My notes, there we go. How far did I write? I wrote till SN1 and SN2. SN2 has a transition state and SN1 has a carbocation. SN2 is favored in basic condition, SN1 is favored in acidic condition. Proportionality constant K connects reactant concentration to reaction rate. Okay. Okay. So we gotta change the camera setup or what? Because I feel like I need to change the camera setup, right? Yep, I wrote till here. Possible product classes accessible by SN reaction. No, I can't copy it. So we got a chloro ethyl chloride. What would you say? What's the name of this? CH3CH2Cl. Is it lagging? No, the video is not lagging. It is lagging. Ethyl chloride, okay, that's a common name. Chloroethane. Bromoethane. Iodoethane, okay. So we got alcohol, alcohol nucleophile, right? Electron-rich compound which donates electron pair. That's the nucleophile. Electron-rich compound. Minus. All are electron-rich. Amine group, nitrile. So this is the next page in the slide, and there's some reactions. It's mainly just haloethane reaction with nucleophile nucleophile like OH, HS, etc. So if I understand this, when there's nucleo with two elements involved with having a negative charge symbolizing electron richness, it replaces the halogen. So also I'm guessing it's not a golden rule. There's gonna be exceptions, but when there's a nucleophile with oxygen or carbon involved with more than one atom going against halogen would most likely result in the halogen being the leaving group. You are actually understanding the main idea. Oh, ChatGPT, thank you very much. You think I'm very intelligent? Oh yes, I think you're the most intelligent human being out there. Thank you very much, GPT. I just wanted to hear that. It means a lot. For a typical SN reaction, Rx plus Nu minus gives R Nu X minus. Alkyl halide. Nucleophile replaces the halogen. Okay. Attacks carbon. Product is ethanol. Nucleophile replaces the halogen. Yeah. No, I'm wondering, your second thought, you said there's a nucleophile with ORC involved and a halogen present. The halogen will most likely... That's a pretty good beginner rule for instant reaction because halides... bad leaving groups. What makes it bad leaving groups? What makes... This is not even hydrocarbons. You can't even say these are hydrocarbons. So I can't even say these are hydrocarbons, but I could say that these bad leaving groups mostly involve highly electronegative atom with a donor atom that gives it the electron rich electronegativity. Is the wordings correct? You're noticing a pattern, but let's refine it because the reason is a bit different. Did I spit? I did. I spit. Damn, the last stream was 2 days ago. Fuck. It's not good. Not good. Oh. I guess time to change the camera setup, right? Yeah. Love it or hate it, we're gonna change it. It's been a while. Oh no, not nice. Fuck. Just a minute. God damn it. I forgot it was entangled. Not gonna lie, I got one more thing to do. Just a minute. Fuck. I forgot to do one more thing. Select. Ping ping. Yep, still working. Oh, what's this one? Which song is this? Wait. Why is it tilted though? Okay. Fuck. SN2, SN1. Okay. SN1 has carbocation. Then it forms the final reaction, while SN2 just goes straight to transition state, which cannot be observed. It is hard to observe the transition state. Hard or even impossible. And then we go to the product. Yo! I just heard someone say hello. Just a minute. 18, 17, 15. Let's go 15. 15, 0, 6, 26, 2. 15 minutes, god damn it. Damn, that's just very... ARL from somewhere. What's up? It's been a while, huh? It's been a while since I saw that name. How you doing? I'm not gonna lie, it's been a long time, yeah? Not gonna lie, I also did not stream for the past 2 days, which is stupid, but you've been busy with school. Oh, school's started. She. How long has it been? Like 1 or 2 weeks since the school started? It's so cool. Yeah, I was also pretty busy with the... I had an analytical lab work, and after the labs I was like, oh. And I did not stream for the 2 days. But hey, we're here. We're here. It's been 3 months. Ah, shh. Makes sense. Well, that's how it is, huh? Wait, so right now you're in class 11th? Is that though? Did I understand it correct? 11th or 12th? '11th. Oh shit! I remember a lot of stuff I learned. Not remember, but yeah, there is a lot of physics, chemistry, mathematische und biologische. Back. How's it going? Are you also doing the other course? Like, are you also preparing for, what's it called? Entrance, along with the 11th studies? Or is it someone else? I feel like it's you. You also? JEE? Yeah, are you preparing for JEE? Along with 11th? Because at this point, it is like a normal thing. When you enter class 11th, yeah, you just gotta... JEE, it's complicated. Oh. But yeah, that's the weird part. Like, it used to be like, oh, you are going for coaching for, entrance exam. But now it's like, bro, that's normal. If you're on 11th, you gotta join the coaching for JEE or NEET. Is it normal? JEE is for engineering. Yeah, I know. JEE is more IITs, and NEET is for the medical school. But what was I saying? It's now becoming common. It's a common thing to go for school. I want to do theoretical physics. That's good. You have an idea on what you want to do. That's good. That is a very good thing that you want to pursue a specific topic. But are you planning to take JEE or any other? I got 5 minutes to upload this video. Come on, man. Fast, bro. Brain, make it fast. ChatGPT, I'ma need your help. What's this? Yeah, there we go. Oh, that's so slow. Ugh. That is the slowest I ever used. I've not taken coaching this year. Oh, 5 minutes is over. I'll take the exam, and if I get it, I'll go there. But then I'll try for better colleges in between in case I applied and get into there for pure physics program. There is another exam, right? CUET? That's the exam for universities. Let me check. CUET. Common University Entrance Test, right? Yeah, CUET. Because if you want to get into, I forgot the name of the university, but there are some really good universities under CUET. And I heard CUET is a bit forgiving. I heard CUET, but it's no way near JEE because JEE is considered the second hardest exam worldwide. Yeah, it's like I get the hard part, but why? Why are we making this hard? Like it's worryingly hard. It's like they're trying to make it. I heard from someone else that these exams, JEE, NEET, are basically trying to get rid of a lot of students. So if I get good JEE score, it'll look really good on my portfolio. Yeah, of course. If you could get JEE, yeah, of course, it's gonna look good. Like that's something you can show as proof that you are reliable. Whoa. Okay. GPT, where the fuck you are? Yeah, there we go. Both are uploading. Yep. Good score is always good. Good scores in important exams are always good. Key factor for good leaving group is how stable is it after it leaves the electron pair, chlorine. No, chloride. No, chlorine. Chloride. Chloride. Hydroxide or alcohol. Chlorine is quite electronegative. I'll probably try for good German university because German physics is considered the best, or Switzerland. Zurich. Ah, shit. Yeah. Germany has they are really specialized in engineering, right? Especially what type of, how do I say that? What type of instruments? Like precise instruments. Germany is specialized in making, yeah, I don't know how to say it, but lot of surgical instruments, things that require really good precision. Germany specialized. Precision engineering. Okay. Yep. chemicals, pharmaceuticals, let's go. Well, yeah, you are right. Germany is really good to study physics. But yeah, not gonna lie, it's good that you know what you wanna do. Let's refine it because the reason is a bit different. The key factor of good leaving group is how stable is it after it leaves from electron pair. When hydroxide leaves, yeah. Therefore, OH. So, theoretical physics. What is it used for? Like, is it like designing cars, aircraft type shit? Like pure physics. So it's less about application, more about completely different from engineering. Okay, okay. More into simulation, you could say. Theory, okay. Mm-hmm. A strong base does not like being its own. It prefers to use its electron pair to grab a proton. OH minus is a strong base, therefore OH minus is a poor leaving group. A strong base does not like being its own. It prefers to use its electron pair to grab a proton. Like more mathematical part of physics. Okay. I kind of understand it, but I think it's more into research, I guess, right? Research part of physics more than application when you go theoretical. Or did I understand it wrong? A better rule for electronegativity instead of saying bad leaving groups involve research. Physics research, yes. We need more research in this world. Bad leaving groups involve electronegative atoms. Bad leaving groups are usually strong bases. This works much better. So, Errol from somewhere. I'm guessing you're back from school? Should be like the time where you should be back from school, right? Or you didn't have school today? Good leaving groups equals weak base. Good leaving groups equals weak bases. Oh, okay, okay. They are stable after leaving. Holidays. Oh, shit. June. I don't know what specific holiday, but okay. That's good. Holidays are good. Bad leaving groups equals strong base. These are unstable with negative charge and strongly want to react again. Why NH2 minus and R minus are terrible leaving groups. Nitrogen is electronegative, yes, yet NH2 minus is still very poor leaving group. Carbon is not very electronegative. A carbon anion is extremely unstable. So it's not about electronegativity, it's also about stability when it's on its own. A leaving group is good if the species formed after leaving is stable. Okay, I need to write that down. SN reaction, leaving group psychology? No. What was the full form of SN reaction? Substitution nucleophilic reaction? Ficaro, substrate no. Nucleophilic substitution reaction. So SN, okay, God damn it, what's the full form? SN. Mechanism and stereochemistry of SN reaction. SN1, it's a tertiary carbon attached to a halide halogen. Oh, it's already 15 minutes. Yo, chill. Chill. A substitution nucleophilic. Oh, that's a weird name. Substitution nucleophilic. So what did they understand? Nucleophile and the leaving group. What's the points about the nucleophile? Strong base. Usually strong base and is highly unstable on its own. On its own. Usually weak base. Yo, I gotta go. See ya. Respect for checking out. That means a lot. And good luck on your studies, gang. Ow. Usually weak base and is highly or is stable on its own. Bad leaving groups involve electronegative atoms. Bad leaving groups works much better. Leaving group is good if the species formed after leaving is stable. Okay, I think that's enough for me. I think I got a pretty good explanation on what the leaving group and nucleophile is. Shit. So, we got water and that water. So bromine or Br halogen leaves forms a carbocation. Water has two ways to attack the carbon. It could attack from one side or the other. And you get two products which are mirrored images, stereoisomers. Stereoisomer. Isomers. Stereoisomer. Planar S2P. Planar sp2, transition state, stereoisomers. That's bad. So inverted configuration relative to the configuration of the alkyl halide. Same configuration as the alkyl halide. Oh, okay. Reactive mechanism and stereochemistry. Homo-LUMO interactions of nucleophile and the alkyl halide leads to backside attack. Halide halide. Okay, so nucleophile comes up. Due to its negative charge, all the negative charged or metal groups, they have some electrons in them. They move to the other side, resulting a partial polarity. But this is negative. How polarity? Where's the polarity part? Is this the polar region, like the plus positive? And okay, so this goes there. So this if the metal groups are positive, they should be attracted towards the nucleophile. Or these hydrocarbon groups. Nucleophile comes up, bonds. The halogen is having 3 bonds are in the same plane. It was not okay. Now it's on the same plane, and then boom, the other side just fucks up. Inversion of configuration, Walden inversion. And that's SN2. So that's the transition state, okay. That's where both electrophile or leaving group and nucleophile is on the same hydrocarbon chain. The purpose. Just a minute, gang. Just a minute. here when the nucleophile comes in for attack, the alkyl groups attached to the carbon attached to the halogen leaving group is now shifting the plane opposing to the nucleophile, which I'm guessing the alkyl groups attached to the carbon are oh no. Fuck, no way. $45, goddamn. So Google just made me a thumbnail for this video, and goddamn, that's the worst shit I ever seen. No way! No way! Fuck, okay. Shit, I gotta use this. Fuck, that's cool. Damn, Google, I did not know you fuck like that. I did not know that. I gotta use this. Where is it? Downloads. There we go. Upload. Disclaimer. The fucking thumbnail. It's fresh from YouTube. Say I slaw. AI. Not gonna lie, it looks much better than expected. Yo. I did not know you to fuck like that. I did not know that. I didn't know that. Okay, I'm wasting my time, right? Yep, I am. We gotta get back on track. Chinese food run, okay. Okay, focus. In which I'm guessing the alkyl group attached to the carbon. Can I say the carbon is a stereo center? I would also like to know the name used for this central leaving group. At some point, both the nucleophile and the leaving group is attached to the carbon, but one of my doubt is there polarity involved? I feel like all the groups involved are negative charge. like the nucleophile, the electrophile, the leaving group, and the alk groups. Tonight, hold on. What is the central carbon called? In SN2, the carbon bonded to the leaving group is called electrophilic center. You'll also see reaction center, carbon, alpha carbon. Reaction center, okay. The carbon bonded to the leaving group is called electrophilic center. Oh shit, that's the name, okay. What actually, I haven't written that. What actually happens in SN2? SN2 is a one-step nucleophilic attack from the backside, leaving groups at leaves at the same time. No stable intermediate. But there is an intermediate, right? There's a transition state. Geometry idea. Carbon is sp3 tetrahedral. When nucleophile approaches, it attacks the opposite leaving group. Why? Because in front side is blocked by the leaving group and the bonding electron density LUMO orbitals and lying to the backside. Bonds do not shift as rigid plane. Instead, the carbon temporarily goes through a triagonal bipyramidal transition state, then flips configuration. Are all groups negatively charged? No, this is major misconception of negative leaving group. Leaves as negative ion, alkyl groups not negative, just neutral. Okay. Only nucleophile and leaving group carry charge, usually not alkyl group. Okay. It's almost about to be 1 hour. It's already 1 hour 2 minutes. What? How is that? Okay, it's like 2 minutes left to be 1 hour. Of a negative OH minus Cn minus HSRO minus leaving groups leaves as negative ion, chlorine, bromine, iodine. Alkyl group not negative, just neutral. The only nucleophile and leaving group carry charge, not alkyl groups. Where's the polarity involved? Yes, polarity is crucial. Carbon is partially positive, electrophilic, halogen is partially negative. That's why nucleophile attacks carbon. Homo-LUMO link your slide. Lone pair of nucleophile. Lone pair of nuclear fire. Yeah, that's this one. LUMO, the sigma star anti-bonding orbital of CX bond. So that's the LUMO orbital, but again, isn't the LUMO, wait, when you say anti-bonding, when anti-bonding orbital starts to fill up, the bond, I need a little bit more context. Sigma star orbital is accessible from the opposite side of the leaving group. Key correction to your, you said alkyl groups are negative. Not true. Neutral. They only influence steric hindrance, stability of the transition state. 1 hour. No, don't set the timer. 1 hour. Okay. I got 2 more hours before class. Not gonna lie. Not gonna lie. I feel like I wanna change subject. I wanna complete the analytical chemistry lab report. You know what? I'll also do that. Like 30 minutes of that. I'm gonna edit the title. I'm gonna edit it on YouTube. Edit the title on YouTube. My hair looks shit. I know. I know. And when I change subject, I feel like it's kind of refreshment to the brain. To the brain. I changed the title, right? Nah. Some bullshit. Not gonna lie. This is some bullshit. Thumbnail. Do you think you could 21:33. $30. Wait, can I do this thing? I always wanted to try this. Add one more desktop. So that's desktop 3. Wait, why is desktop 4 having close? Yeah, whatever. And desktop 4, analytical chemistry lab help. Open gang. Pretty fast, please. Open it pretty fast. That's what I mean. Not pretty fast. Like pretty. No. Yeah. Why am I over explaining it? Why is this here? What? Desktop. What? I thought that's the whole purpose. Desktop 4? Oh, the same app? Can I get the new window? No. No, I can't. So desktop is useless. Fuck. I gotta send an email. Just a minute. Oh, I gotta be more systematic, gang. Uh, if it's not possible time. Did I just? Did I just? Did I? Did I just? Okay, that email is sent. So gravimetric analysis, I did this, right? I did this. That's done. Now this one, yeah. TLC. I haven't done this. And which one is this? Okay. Where's my cup though? Okay. UV, I did this. Gravimetric. Iron, copper, bismuth, chloride. I haven't done this. I have not done this. Just a minute, gang. I gotta use my phone for this. One. Nah, fuck this, bro. I'm not gonna. Bro, what the fuck is this song though? Okay, I'm gonna turn on the footage. Don't get scared. Oh shit, phone stopped working. It's not working. You could see my face through tablet, but not too much, okay? Not too much, not too much. Is it aligned? Damn, the hairline. Focus! 30 minutes? Okay, I guess we're going back to organic chemistry. God damn it. 1 hour. 45 minutes. 30 minutes. 15 minutes. 20 minutes. Where's the organic now? Okay, this is where it was. Okay. So if I understand this, the nucleophile is adding electrons into the anti-bonding orbital to the electrophilic center. But if I anti-bonding the more electrons are in it, the more likely it's gonna result in lesser bonds. Oh, you're thinking in the right direction, but that's how it's gonna say. Yes, you're very close, but the key misunderstanding is the nucleophile does not fill an anti-bonding orbital. They make the bond weaker directly in the final product. It uses anti-bonding orbital only as a reaction pathway, not as a final state. Yep, I guess, bro. After some point, it's like learning chemistry is like, I guess, bro. Whatever you say, bro. Oh, it's not like the joints tries to get into the electrophilic center by pushing in electrons on the anti-bonding orbital, even though if you push in electrons into the anti-bonding orbital, it results in breaking bonds. But hey, it first puts into the anti-bonding orbital, and after that, it's gonna change to a normal orbital. Oh, okay. I understand. I get it. I get it. What LUMO means in SN2 for an alkyl halide. Carbon hello bond. Sigma bond has corresponding. Yeah. Sigma star. Sigma star is empty, located in the backside of the carbon, the correct shape for attack. LUMO, accepting shape of the molecule. What the nucleophile actually does. Nucleophile overlaps with sigma star LUMO. Electrons start flowing in the region, but this does not mean a stable sigma star bond is formed. Instead, a transition state is formed. Old CX bond is weakening, new CU and C and U bond is forming. So both happen simultaneously. Why filling the anti-bonding weakens bonds? Your intuition, the general idea is correct, but context matters. Sigma star is filled permanently, bond becomes unstable, breaks. So I'll end this with one more statement that I wanna, if so, when the nucleophile starts attacking the LUMO, antibonding, would it result in switching of the bonding anti-orbital in a way that the halogen attached to the electrophilic center is now filled its electrons in the antibonding orbital, resulting in the breaking of bond with not correct. CX bond has sigma filled, antibonding empties. This does not relocate electrons into the halogen. Instead, it creates C3-center transition state. Key point you missed. Halogens get electrons in antibonding. Instead, the original CX bond becomes unstable because electron density is redistributed into a higher energy antibonding region, weakening it until it breaks. Wait, what? The carbon-halogen bond, sigma bond, becomes unstable because electron density is redistributed into a higher energy antibonding region, weakening it until it breaks. It takes the bonding electron pair from CX sigma bonds, not from sigma star. So sigma bond electrons go to X. Sigma star was only involved in the interaction pathway. Transition state forms, old bond weakens, new bond forms, leaving group departs with bonding electrons. Okay, oh fuck, I'm going in too deep. So it's not too deep, but I'm wasting a lot of time on this. So after the transition state, the halogen takes away the bonding orbital electron, and the electrons filled in the anti-bonding orbital filled in by nucleophile takes over the bonding orbital, which electrons were took away by the leaving group. Did I get that right, please? Not correct, okay. I like that. It's telling me what's correct and what's not correct. What actually happens in SN2, clean version. Before reaction, CX bond, sigma orbital with 2 electrons, antibonding empty, nucleophile lone pair. During attack, nucleophile overlaps with sigma star, carbon nucleophile bond. Electrophilic center nucleophile bond starts forming. Electrophilic center halogen bond starts weakening. Now you have 3-center transition state. No orbital is fully replaced yet. After reaction, final products. What happens to the electrons? Leaving group. X leaves as X minus. It takes electrons from the original CX sigma bond, not from sigma star. I understand that. New bond. Nucleophile electrons form a new sigma bonding orbital with carbon. It is not sigma star getting filled. It's a new bonding orbital formed after reorganization. Key correction to your statement. Electrons in the anti-bonding orbital takes over the bonding orbital. No transfer of sigma star into the bonding. Instead, sigma star is only temporary interaction orbital. Final bonding comes from new orbital formation. Okay. Mechanism and stereo. SN2. Homo, LUMO, interaction. I hate it when it's lagging. Yeah, it's everyone hates it. I understand. I understand. So we got the carbon. Bond. Electrophilic center. Sigma star. LUMO. Anti-bonding orbital. Empty. So when nucleophile comes in, backside attack, transition state, after that Final product. NU starts filling the anti-bonding orbital, sigma star orbital. 15 minutes, goddamn. Now, new sigma bond forms, not sigma star. Transition state. Electro center. Leaving group. Nucleophile. Reverse configuration of the alkyl groups. It's called the Walden's inversion. So that's the Walden's inversion, but there's the other one, mechanism, right? SN2, SN1 mechanism. S-chem, stereochemistry, yeah. 20 minutes. Oh, tertiary carbon. I can't draw a line. I can't draw a line. That's sad. Nucleophile, and we get two planar sp2 transition state, two stereo isomers possible. Yo, I just heard a hi. Devoto did. Yo, what's up? Hello. Appreciate you for checking out the stream. Yup. We got two transitions, stereo isomers possible. So removing water. Fuck, where's the mouse not working now? So after removing the hydrogen, what you get? You get OH. OH, C, R, R double dash, R triple dash. C. After removing the hydrogen, we get something like same configuration. Inverted configuration. Okay. Stereo isomers possible. In SN1 reaction, now in SN1 reaction, if there's a stereo center, then there's possibility to so stereo isomers as result. So how is this number gonna change with increasing number of stereo centers? In SN1 reaction center that becomes planar can be attacked with motion, giving stereoisomers racemic mixture. Oh, there was other names. But the number of possible stereoisomers depends only on how many stereocenters exist in the product, not directly on SN1 itself. A molecule has n independent stereocenters, then the maximum number of stereoisomers. $30, goddamn. General rule. N stereo center two raised to n possible stereo isomers. Effects of SN1. Solvent effects. Solvatization of anions by protic solvents through H bond. Solvatization of cations by solvents via donation of electron pairs. What is this though? What are we talking about? Can you explain what this... This page is about how solvents influence SN1 and SN2. What is solvation? Solvation equals surrounding ions or molecules with solvent molecules. This stabilizes charge species. Solvation of anions happens strongly in protic solvents. Protic solvents equals OH, NH bonds. Examples: water, alcohol. The positive H end of water attracts the anion. Anion becomes less reactive. Nucleophile strength decreases. The positive H end of water attracts the anion. Anion becomes less reactive. Nucleophile strength decreases. Solvation of cations, positive ions. Oh, fuck, I forgot. I gave ChatGPT a prompt. This page is about how solvents influence SN1 and SN2 reaction by stabilizing ion. What is solvation? Solvation equals surrounding ions or molecules with solvent molecules. Surrounding ions or molecules with solvent molecules. This stabilizes charged species. Solvation of anions happens strongly in protic solvents. Protic solvents... Why is the mouse not working, eh? Protic solvents equals have OH or NH bonds. It's not a mine. NH nitriles? Water, alcohol, ROH. They stabilize anions. Anions like chlorine, hydroxide, cyanide. They get surrounded by solvent molecules via hydrogen bonding. The positive H end of water attracts the anion. Effects: anion becomes less reactive, nucleophile strength decreases, solvation of cations, positive ions. Cations be like cation, carbocation, sodium. Protic versus aprotic solvents. Protic solvents stabilize both anions and cations strongly, especially strong at stabilizing anions. Example: water, alcohol. Effects: slow SN2, favors SN1. Fuck, I should have done that. Okay. Okay, it's like 3 minutes for 45 minutes. Gotta be faster, gang. I still haven't understood what the protic solvent part. Solvatization of anions by protic solvent through H bond. Solvatization of cations by solvents via donation of electron pairs. So if it's a ion dipole interaction between a negatively charged species and water. So if it's a negatively charged species, the hydrogen atom surrounds it, positively oxygen atom. DMSO can solvate a cation better than it can solvate an anion. Cation is going to be positive. So the oxygen part, the negative part. Surrounding ions are molecules with solvent molecules. This stabilizes charged species. Solvation. So are we talking... So are we talking about stabilizing the leaving group or the nucleophile before attacking? Solvation of anions, negative charge, negative ions happens strongly. How they stabilize anions? Anions like get surrounded by solvent molecules via hydrogen bonding. So if it's a how is this hydrogen bonding? Anion becomes less reactive. Nucleophile strength decreases. So we're talking about nucleophile, okay. 45 freaking minutes. I gotta charge my phone. I should. I haven't touched my boy the whole day. Both, but the effect is different for each species. Solvation of nucleophile before attack is the most important case of SN reaction. The nucleophile is surrounded by solvent molecules, especially if it's an anion. Example, FX nucleophile becomes KH, it's a lone pair, it's less available, reactivity decreases, this affects SN2 rate, solvation of the leaving group. The leaving group is also solvated, stabilizes X minus in the solution, making leaving group departure easier. This helps both SN1 and SN2 directly, okay? Solvation of the carbocation. Solvation means stabilizing, literally, okay? Using the solvent ions or solvent molecules. Okay. Solvation affects all charged species, but nuclear effects of SN reaction. Be right back, gang. We're talking about solvent, okay? Yo, somebody just said my name on the chat. JOSHABRAHAM. Oh, you got it right. Mahid, how you doing? Are you here? Did you get here? How you doing, brother? Cause I haven't seen you though. Yes, sir. Oh, you're here. I haven't seen you yet. Maybe because I was yesterday. Great. Yeah, maybe did you knock or something? Yeah. What was I thinking? Yeah, I was having some lab work recently, so I was not able to get use the kitchen that often. It was me. Okay. Hells yeah. Okay. That's good to know, cause I'm not schizo or anything. That's good. Uh, what was I thinking? Yeah, I was having some stuff at the university, and maybe that's why I couldn't see you. But hey, eventually. So how was the trip? Was it good? Was it? It should be. It should be good, right? Of course. I did see some football video. I see some biking video, and maybe walking through a street. It was amazing. That's how it should be. Hell yeah. Good to hear. I think I only seen some shorts, but yeah, that was cool though. Not gonna lie, the GoPro is looking good. The quality is good. We will have a chat in the kitchen, yeah. Yes. Eventually we're gonna just see each other. Study man, best of luck. Respect. Okay, would you explain what this part is mentioning about? Man, long way to go. Fuck. This part is explaining why SN1 reactions become faster in polar, especially protic solvents. Again, when you say these words, I'm not very clear. I'm guessing water is a polar solvent, right? It has molecules that has definite polarity. Water molecule, oxygen, hydrogen, positive, negative. Especially protic. I don't know what that is. SN1 happens in two steps. Step 1, slow rate determining. This is bond breaking, formation of ion, creation of carbocation. This step controls the reaction speed. Why solvent matters here? Before reaction you have a neutral molecule. You form charged particles. Wait. Fucking ats. And the mouse is just gone. Okay. So you have a neutral molecule. You form charged particle. Charged, charged, charged particles. Cha- charged, charged particles. Particles. Oh shit. Particles. That's kind of inappropriate. Apologies. So the system goes less polar, more. You form charged particles. R star carbocation, R plus carbocation, L minus leaving group. Leaving groups goes with the electrode pair, right? Yeah. what the polar protic solvent does. Polar protic solvents like water, alcohol surround and stabilize ions through solvation, especially stabilize. Okay. Energy ideas like this blah blah blah, meaning activation blah 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 blah. A bit. I know water is a polar as water molecules are polar or has polarity. The reaction can either be sped up or slowed down by a more polar solvent compared to a reaction with non-polar solvent. The formation of polar intermediate is the rate limiting step. Polar solvent. Wait, so if you add polar solvent, it as one. So it goes down. That's what you're talking about. What goes down? Free energy. So it's easy to. You know what? I gotta take a break. Damn, my limit is like 2 hours. That's not good. This is not good. I got 2 minutes, 1 hour, 1 minute 25 seconds to get the 1 hour limit. I'm gonna close it. I'm gonna end the stream, gang, because I gotta eat something before I head to class. You understand? You understand? Yeah. So I'm gonna go outside, go get something to eat, head to class. Peace out, YouTube.